This is Algebra 1, Term 4, Lesson 6, Quadratics in Action. We will begin with a Desmos activity, then we'll do a little bit of work in graspable math, and we will finish up with a team task about a falling rock. Let's start with our Desmos activity. This is the Desmos activity, Quadratics in Action. It should take at least 30 minutes, probably 45 minutes to complete as a class. The first 12 slides, first 12 screens of the activity are review. And you'll see that there are a total of 15 screens. My recommendation is to let them work independently on the first 11 screens. On screen 1, they will drag this purple point to the initial height, and it will say correct on the graph when that is in the right spot. On screen 2, they will take the purple point and place it at the time when the object reaches the ground. And that will be another one that says correct when they get it right. And then the third one is the maximum height. So they will drag the point to the maximum height and correct will appear. Here's another scenario. This is a book signing. Hopefully your kids know what that is. You may walk around the class while they're working independently, and if you have students who are confused about what is a book signing, that may be a conversation you could have with the whole class. But as I said, I would have them working independently through these slides. So here, how many books were sold on the day of the book signing. Here's another example that's very similar to ones they've already done where the projectile motion. So what is the initial height? When did the baseball hit the ground? What is the maximum height in feet? These are all multiple choice. These all give them immediate feedback, so they will know if their answers are right. How many seconds? How long is the rocket in the air? So they will type a number in the blank. It will tell them if they are correct. What is the maximum height of the rocket? This is measured in feet. How many seconds did it take for the rocket to reach its maximum height? Again, they will type a number in the blank and check their answer. It will give them feedback on their answer. Now, once you've gotten through the first 11, that should be review for all of your students. Here's where the meat of the lesson begins. And so in this case, they are going to restrict the domain of this function for this situation. They do that by coming to this row and clicking here and typing in curly brackets. They can move this over, so tell them to do that if they need more space. And then they will type in here their function. If, God forbid, they were to mess it up, tell them to click here and reset, and it will go back to the way that it was. So if they accidentally delete part of their equation, which happens, or delete one of their points or directions, they can always reset. Have them type their domain there. On the next one, they're going to type and label a point for the maximum height. So they will click on the graph to find that, and then they will explain what both of the numbers mean. So what they do, and I'm just going to make a point up to show you, is they just type in here a point that they think represents their maximum height. I'm not going to do it because I don't want to ruin the activity. So I'm just doing 0, 0. They will click on the word label, and then they will type at 0 seconds. The height is 0 feet. Well, it's not feet though, is it? It's meters. You may want to point that out since we're doing meters for the first time, I think. We've been doing feet up until this point, so this is another thing to maybe talk about. This is no longer in feet, guys, so pay attention. But that's what I'm asking them to do here, is use words and numbers to describe this point. Since the order pair is not showing up, put the order pair in there as well. And there's the whole thing. And it's notice how it's on the graph. Of course, that's not the correct point. So anyway, they will type in their own there. The next point they're going to label is the initial height. So what point, what order pair on the graph represents the initial height? Explain what both coordinates mean. So there's two numbers in this point. I want to know what each one means. And then the final one is labeled the 0 of the function that applies in this context. So one of the zeros is in the context, it's within the domain of the function. Since they've already restricted their domain, they probably won't even see the other one, so they won't think about it. But if they haven't, they might accidentally label the wrong one. So talk about that if you need to. I've got some sample responses for this screen, so be sure to check there if you need them. Okay, this next one is about a rock is dropped. Now we are transitioning away from the graph, which was screen 12, which is kind of a summary of everything they should know up to this point, to now we're going to look solely at the equation. How could we just use the equation to figure out a time when the object reaches the ground? First, I want to know how long will it take until it reaches the ground. Now, some of the kids will automatically want to type it into the calculator and graph it and look for that time by looking for the zero of the function. And I'm not opposed to that at this point, but the problem is they still need to answer part 2. Show the process that you could use using only the equation to arrive at that answer. So they need to get to the point where they're actually using substitution and solving to get to that answer. Take your time on screen 13. I would say this is the most important screen of the entire assignment, so don't let it go too quickly. Let them really ponder what they're doing and why it works. Now, if you haven't been pacing, you really should at this point, opening one screen at a time as they go through these last few screens. So this next time, we are just solving an equation. So using this equation, which is given, notice there is a question mark for the initial height, but I give them the initial height in the text at the top of this slide. So they should substitute in the number that they know is their initial height. They are working in meters and seconds, so meters is important, a different unit. And then they're going to write and solve an equation and show the process to get the time. Now, if you've never done this, I often would have them do these types of problems on mini whiteboards, and they would use their Chromebooks and snap a picture, and they would place that picture in this slide. So when they take their pictures with their Chromebooks, they will click this little dot, this square here that says upload image, and it's going to tell them to click here, and they can browse on their device for that photo and put it in. Now, the downside of that is some students want to take their pictures with their phones, and then unfortunately you have a ton of permissions issues with your district issued devices and their phones. They almost never work together, so they do need to use their school issued device to take the picture if they're going to use whiteboards. The other option is to just use the math tool here and type in step by step what they did to solve the equation. And they could also insert text explaining each step as they go. And so we've come to the last screen of our Desmos activity, and this really is the whole assignment in this one screen. Learning how to use inverse operations to solve an equation to locate an x-intercept of a graph. And so that's what they're doing here. All the steps are here, and then these are the steps mixed up on the right, and they will drag these around and they will put them in order from the initial function down to the final solution. So, and there's only one proper order. If you would like, you could put your dashboard up for the class and anonymize the dashboard so that their student names are not appearing, but a mathematician's name will be appearing, and they will be able to see if they've gotten this right or not. So since it's new, you might want to do that. If you want, you could have a conversation here about what happens to this plus minus. What is that and why is that there? Good conversation to have. Okay, let's go back to our slides for a little bit of graspable math. So the first screen in solving quadratics is to basically watch a video to learn some gestures. So what I've done is they've worked a problem out in graspable math in a video, and I want them to work the exact same problem out in graspable math and insert their work on this slide. So the first thing you can do when you get to math.new is click on the gear and click on dragging and simplify and save changes. Next, you will type your equation into graspable math. Now, to solve, we can't distribute, but we can divide. You don't want to square, you want to unsquare. So take the square root by dragging the 2 over to the 25. The square root of 25 is 5, so click on the square root symbol to reveal that 5. Now notice there's a plus and a minus. That means there's really two equations here. So first I added the 9 to the other side, and then I'm going to double tap the plus minus to get two separate equations. Click to simplify. The two solutions to this equation are 14 and 4. Next, we're going to move over to a quadratics activity in Graspable Math. You may choose to put some of these into your slides and not have them do this activity, because basically they're doing the same thing, and all of this can be done in math.new. This is just a nice way for them to self-check instead of you checking, because these are goal state questions. So I'll go ahead and do the first one with you to show you how this works. So on the first goal state question, you'll notice there are two solutions down here. So we'll need two. I'm first going to add 25 to both sides. I'm going to simplify here and simplify here. And then we're going to take the square root to both sides. So you drag the 2 over to the 49 and it square roots both sides. You tap on the square root symbol to remove it and get 7. But you still have plus minus. To make it look like this, you double tap on the plus minus and it will separate. And then you can continue to the next slide. The last two are just multiple choice questions, and 2 of these will be solutions. Same here, 2 of these will be solutions, and they can check their answers so they'll know if they're right. We'll go back to the slides to finish this assignment. So on this one, they're going to solve with math.new. So the students will type an equation, but they will not type the h of t. They will put a equals 0 instead, and they will solve that equation. And when they get their answer, they will insert it on this slide and answer the question. How long will it take for the object to reach the ground? I do have guiding questions for the students, so let's take a look at those. Down at the bottom, it's saying what part of this equation is 0 when the object is on the ground. All right, the next one, this is changed, and I'm trying to point them to this by giving them a guiding question at the bottom. Why is the coefficient of t squared different from the negative 16 that was on the last slide? Well, if they haven't noticed already, the units have changed from feet to meters. And so I do want them to pay attention that we don't always use negative 16. We sometimes use negative 4.9. That was in our Desmos activity. It's in our slides. And so they need to be flexible and realize the models are a little different. The reason that's important is because of the team task, which comes next. So let's take a look. So students will work with their teams to solve these problems. There is no explicit direction on how I want them to approach the problems. So some will do graphs, some will do equations, and some will do a combination. Of course, I'm going to applaud and celebrate the ones who show me multiple representations, because that's always appreciated on these team tasks. So here we have a rock being thrown off of a bridge, or dropped off of a bridge, and it's being dropped over a platform, which you cannot see in the picture, but they have to imagine it, and the platform is being raised at a constant rate. So really they have two separate models here, and they're using those two models to come up with a point of intersection. So we're kind of looking at a system. When did the rock hit the platform? So I give them nothing but that, so they would have to first notice the units are feet, so that's some guidance there. They could use problems they've worked before like this, constant rate of change, where we've seen that, and tables, graphs, and equations all work for this application. So they could use all of those or any of those to solve this problem. I think most of mine got through this task in around 20 minutes. It was pretty fast. What they did is they worked the entire thing out on the board. Some of them brought their Chromebooks up so they could use those to generate their graphs, tables, and then check out their equations. Maybe even in math.new they could do equations. Once they've come up with their work, they could take a picture of the work that they've done on the board, and then they will place it on the next slide. So the next slide is just a blank slide with a title, and I tell them in their show notes, paste a copy of the work that you've done with your team on this screen. And this concludes our Quadratics in Action lesson. Y'all have a great day.